thank you everyone for joining us for the winner ceremony and for participating in the Hackmakers' very first innovation challenge, the Build with AI Global Hack. This is the first of a biannual global event centered around the application of best practice data science and AI processes to address global challenges. This year's challenges were themed around the global COVID-19 pandemic, with over 4,000 participants, 250 mentors, all from over 70 countries and 20 time zones, working together to produce meaningful solutions. We'd like to thank our generous sponsors, Oracle, Google Cloud, Amazon Web Services, and IBM for making this event a reality. We'd also like to thank our community partners, Black Nova Group, Antler, Pact Publishing, and Dedicated Academy for their contributions into our prize pool. Without further ado, please welcome Cassie Kozyrkov, Chief Decision Scientist at Google, who will announce the winner of the Global Showcase Challenge.
Hi everyone, I'm Cassie Kozyrkov. I lead Decision Intelligence at Google, and today it is my great pleasure and privilege to announce the winners of the Global Build with AI Hackathon. The event is a biannual global hackathon centered around data science and applied AI, aimed at solving our world's most pressing challenges. The July 2020 challenge was themed, unsurprisingly, around the COVID-19 pandemic. And we got more than 4,000 participants, over 250 mentors from over 70 countries, and, goodness, at least 20 time zones. All these folks worked together to produce meaningful solutions. And it was a pleasure and quite a challenge ranking the top submissions. But without further ado, here are the rankings. In fourth place, the AI Vision team, represented by Subham from Mumbai, India. This project was all about analyzing people's gait to classify whether people were coughing or sneezing. Super relevant. In third place was the face mask detector team, represented by Mini from Udupi, India. This was an AI vision project classifying, yes, you guessed it, whether someone is or is not wearing a mask. In second place was COVID Doctor, the team represented by Subham from Delhi, India. What's awesome about this project is that it explicitly aims to take some of the weight off of overstrained emergency rooms. So this project combines a chatbot with computer vision to check pulse and breathing rate. Cool stuff. And now, in first place, the winning team, represented by Mohamed from Cairo, India, is the AI-assisted social distance monitor. What I love about this project is that this is so much more than just a social distancing violation classifier. This project creates heat maps of social distancing violations in a public space. So imagine this, a narrow public walkway with some prettily placed garbage cans, because that made sense in the world as it was last year. And now people going about their business, wanting not to violate social distance, end up crowded together because of a poorly designed public space. To identify these bottlenecks and think about redesigning public spaces so that people can easily socially distance, we need technology. And that is exactly what this project sought to achieve. An intelligent way to think about redesigning public spaces. That's a wonderful project. Congratulations to that team, and a huge congratulations to all of our finalists and all our great participants. It was so hard to choose the winners. Thank you for building with AI and inspiring us all.
Please welcome Cherie Ryan, Vice President and Managing Director of Oracle ANZ, who will announce the winner of the Data Visualization Challenges.
Thank you for all the great participants for all their efforts during the #BuildWithAI hackathon. And congratulations to the Hackmakers. They were absolutely amazing. It's been a real massive challenge, and we've had people from across the world working together as a combined team. So deciding on the winners of the visualization challenge was very difficult. We focused on COVID-19 and how it affected jobs. The teams needed to visualize the analysis and the trends and finding out how jobs were affected, either positively or negatively. We looked at two different groups, the storytelling group through data visualization and the better user experiences and the use of data. In the end, we were looking for teams who saw data very differently, how to discover insights and unlock possibilities, and how to make use of that information to make conscious and positive decisions. And the winner is Team Maverick. My warmest congratulations to all members of this global group. I look forward to seeing where you go with this solution. Good luck.
Please welcome Steve Nouri, Advisory Board Member at Hackmakers, who will announce the winners of the Predictive Algorithm and Natural Language Processing Challenges.
All right, now it's time to announce the winners for our final category. It is the Natural Language Processing Challenge. We asked the participants to use natural language processing algorithms and analyze the text data, either social media or news feeds, for some interesting insights and correlations. The runner-up is the team Social Pulse, represented by Senthil. And the winner is Informatic Warriors, represented by Supriya. Congratulations to both of them. Thank you.
We should understand that based on the report from Oxfam, 500 million people could be pushed below the poverty level due to COVID-19. This is a really huge social and economic impact, and this is due to poor sentiments across industries and people, which has resulted in heavy loss of jobs and blow to many businesses across the globe. This has in turn resulted in lesser consumer demand, which has significantly slowed down the economy, pushed all the countries into recession, and who knows, depression is faintly visible too, but we certainly don't want to go there. And governments are trying really hard to address this impact, bring their respective nations back on feet to go north towards economic growth. Hello, this is Team Sociopulse, and we are here to save the nations and respective governments to help them make decisions faster, proactively driving the consumer sentiments as opposed to reacting to them. With the current pandemic, the only way the governments can connect with people is through social media, and with a given time, we have considered Twitter for sampling of consumer sentiments. So we as a team made a prudent decision to help governments with the decision-making support tool to make the right step forward for three main reasons. 1, to increase consumer demand. 2, for businesses to feel confident to reopen. 3, to bring people out of fear. It is understood that governments delay the decision making because of the responsiveness. So we are coming about with a solution that can help the governments with a decision support tool based on real-time social sentiment powered by NLP. And these would be based on the Twitter consumer sentiment, is the most common text classification tool that analyzes an incoming message and conveys if the underlying sentiment is positive, negative, or neutral from the public. We've implemented this using the Stanford-based package Zhuge that extracts sentiment and sentiment-derived plot arcs from text using a variety of sentiment dictionaries. And for NLP modeling, we've used topic modeling, which is an unsupervised statistical model building approach used to discover the latent abstract bunch of words called topics in large clusters of text. It is a repeating pattern of co-occurring terms in a corpus. Latent Dirichlet allocation was applied for topic modeling to infer the different topics of discussion and to determine the overall feelings, to bring back our focus, to reduce the lead time for decision making by the government. And this would result in potential savings for the government in billions of dollars with invaluable benefits, ultimately increasing the consumer sentiment. We were a team that was spread across the globe and which was quite a challenge to bring this to a logical conclusion in less than 3 days. End of the day, what we want the governments to achieve is to have the pointers in front of them to show these behavioral patterns which can increase the consumer demand by improving their lifestyle, and businesses should feel that there is a demand as a result of people trying to increase their lifestyle. And to address people's fears, government should actually run targeted campaigns by increasing awareness and segmenting groups. These are the next steps that we are planning to improve this model. We are Sociopulse, and we would certainly be there to make a difference in this unprecedented situation to help governments and countries, and more importantly citizens, to be back on track. Thank you.
Hi everyone, my name is Supriya Medapati and I'm representing Team Infodemic Warriors. So we are fighting an infodemic in the midst of COVID-19 pandemic. In these times of fear, panic and anxiety surrounding COVID-19, general public turns to social media to communicate their opinions, fears, emotions, and get information. And more often than not, we see that a lot of information is being shared without validating its authenticity and accuracy. At a time when reliable information is key to public health, proliferation of misinformation, pseudoscientific news, and fake news is sometimes spreading faster than the facts. So what can we do about this? We wanted to investigate how we can leverage data to emphasize the impact of the infodemic and how it impacts public sentiment. So essentially, let the data do the talking. As Peter Drucker said, what gets measured gets managed. So the solution we have is to utilize NLP to assess the tweets of media and influential personalities and how it influences public sentiment. Understand public perception and the influence of misinformation on public sentiment, to help policymakers with data-driven decision-making, to inspire media and influential personalities to be more cognizant about what they're sharing, and also to wake up general public to be more conscious about their news consumption. The process, we started off with defining scope and use cases. We gathered data, we pre-processed the data, we analyzed the data for sentiment, we visualized the data using Tableau and insight gathering. So we restricted ourselves to US only because of the ease of gathering data. We restricted ourselves to Twitter data only because it was easy to gather public sentiment due to retweets compared to web articles where we couldn't. We initially planned to conduct the analysis for 4 months, but we restricted ourselves to 1 month because of the time being taken for hydration. From data gathering standpoint, we collected data sets under 2 categories, the public tweets and media or influencers tweets. We collected the top US media Twitter handles categorized by political sentiment and factual correctness, as well as the top public health officials who are considered trusted health officials. We've also put together the data that we've used here and also certain data that we investigated, but we could not use because of the restrictions that we mentioned there. From a data pre-processing standpoint, we collected tweet IDs and hydrated them. We removed hashtags and URLs. We performed tokenization, punctuation, removal of stop words, abbreviation expanding, stemming, correction of spellings. From a data analysis standpoint, we identified key global events like the recent event of Trump supporting and wearing a mask publicly, the whole mental health situation around COVID-19, and a couple of conspiracy theories linking 5G technology to COVID-19 or the conspiracy around Bill Gates and vaccines. We prepared topic query phrases and keywords. We generated BERT sentence embeddings for both tweets and topic queries. Look at sentiment analysis. We can see for the situation or for the event where Trump started wearing a mask and supported mask wearing. Most of the highly factual media and media which reports mixed bag of information are reporting it as a negative event, or the average sentiment score is negative. However, media which is generally reporting factually incorrect data kind of reports it as a neutral event, and there is a lot of positive sentiment around it. Though a lot of people are not retweeting that data, as you can see, there are certain cases where they are indeed retweeting. For example, this case, we see that the true number of US COVID cases so far could be 6 to 24 times. This is not real news. This is just a conjecture, and this is being shared a lot, and we need to investigate why. So what next? We want to expand to a larger data set to include a bigger time frame and larger set of media channels and influencers. We would also want to look at various concerns health officials and public officials might be having. We want to look at more events and conspiracies. We also want to create a go-to dashboard for the public. And thank you so much. I'd like to thank Bruce Hoffman and Karthik Subramanian, our mentors. We also want to thank Hackmakers for this opportunity to get together. Thank you.
All right, now it's the time for the most interesting category, in my opinion, the prediction challenge. The participant needed to predict the number of new COVID cases in the US for the next 20 days. That makes it very, very exciting because essentially we asked them to predict the future and we had no idea how it's going to turn out. The accuracy was only 50% of the weight. And we also looked at the technique and the process they use to make the results. We have received many high quality submissions and it was too difficult to pick the top 4, but our awesome judges finally delivered the verdict. And here's the result. The runner-up used SEIRS epidemiology model and the genetic algorithm for prediction. It's the team Make Unicorns Great Again, represented by Raquel Perez Arnal. Congratulations. And now the winner is the T-Cube represented by Tarak Rapulo. I hope I pronounced it right. Congratulations, Team Cube, and looking forward to the next one. Thank you.
The sudden appearance of COVID-19 has changed the world as we know it. Accurate predictions are a key tool to make proper decisions and foresee future issues. Our proposed predictive algorithm combines epidemiology models and genetic algorithms. As epidemiology model, we decided to use SEIRS, acronym of susceptible, exposed, infectious, recovered, and resusceptible. However, this model depends on a set of parameters, and its resulting prediction changes based on them. So we want to find a set of parameters that better fits the current curve of positive cases, expecting that the model will generalize to the following dates that we want to predict. We propose to estimate the best set of parameters based on a genetic algorithm. The genetic algorithm considers several sets of parameters, recombines them, and makes mutations to look for the parameters that better fit the current curve. We estimate parameters for each state separately, obtaining a model on each one based on its specific conditions. Finally, aggregating results from each state, we obtain our final prediction curve. If there are no changes in countermeasures, we estimate over 6 million positive cases by the 15th of August.
Hello everyone, thank you for the opportunity to compete in the Build with AI 2020 Hackathon. Our team comes from India, Spain, and the United States, and our solution is T-Cube, Track the Trajectory. Given the significant uptick in COVID-19 cases and deceased, and the fact that COVID is not going away anytime soon, our team set out to use data and statistical analysis to stop the spread of the virus. With over 4 million cases, the United States requires dire intervention with new technology to flatten the curve. Our mission was to build the dashboard with forecasts to help policymakers take substantial steps to flatten the curve. We use open source data to forecast confirmed and deceased cases and deploy them in the Oracle platform.
Compared to the market of other data models and machine learning algorithms, T-Cube is uniquely qualified for implementation because of a hybrid modeling approach of epidemiology and statistical techniques. We incorporate three core features: a time-dependent SEIRD model, a data-driven approach rooted in epidemiology, and a generic model with minimal assumptions. We also differ significantly from other models in terms of the following. Using an epidemiological model helps us in overcoming the disadvantages of a pure ML-based model. It also helps us in actually capturing the real dynamics of the disease and is self-adaptable. Plot here shows the actual versus forecast of confirmed cases for New York for the past 21 days. The mean absolute percentage error for confirmed cases for New York is 0.91%. On the other hand, the MVPE for deceased cases is 0.09%. Seen here is the tech stack for T-Cube. The dashboard is built using HTML, CSS, and JavaScript, and the model is written in Python. We initially deployed the dashboard on Azure, but then shipped it to Oracle for a series of use. This is a little introduction to our dashboard, where you can see all the different features incorporated in our web app. You can see the historical data, the heat map, the forecast tables, and the plots. This right here is a little gif of what you can find on our website.
To walk you through our progressive web application, we'll go through a demo of T-Cube, which includes a walkthrough of our interactive maps, historical COVID-19 data table, the forecasted data tables, and graphs for the next 3 weeks. There's also an option to view a table of forecasts for each day over the next 3 weeks. Here are the assumptions for our data model. You might have seen them in our dashboard as well. We aim to deliver the following use cases for our model, including forecasts to assess and adapt, hotspots for proper distribution, and an API for research purposes. We intend to serve government organizations, healthcare institutes, nonprofits, and researchers. We also plan to adapt a pay-as-you-go pricing model along with licenses for corporate entities. Thanks to our 4-point initiative, we now have a solid plan to help flatten the curve. We also hope to grow our solution considerably using our 3-step timeline for scaling internationally. Our team comes from some of the most COVID-affected parts of the world, and we hope to make significant changes with our model. Thank you for watching, and please feel free to contact us and support T-Cube in addressing COVID-19.
Last but not least, please welcome Ian Opperman, Chief Data Scientist at the New South Wales Government, with some parting words for the event.
Never before has data been so important. What the last few months have shown us is that data is absolutely essential to understanding what's going on, to helping to prioritise, and also to work out what to do next. My priorities for the year coming forward are data sharing which preserves privacy, helping that data sharing to work across state and Commonwealth boundaries, and also to continue that journey around use of machine learning and artificial intelligence built on top of data sharing and use. This is an extraordinarily exciting time, and I hope we don't lose some of the gains that we made during the COVID crisis. I look forward to the coming year.
We hope you've been inspired by some of these amazing solutions we've seen submitted for this hackathon. Thank you again to our participants, mentors, and lead mentors. You are the hackers and makers that make this organization tick. Over the coming days, we'll be distributing all the prizes, participants, finalists, and winner badges to the amazing teams behind these solutions. But we don't want to just celebrate winners. Our team and community partners have been busy helping us build the official After Hack Pack. This special guide will go through each of the steps required for you to take a solution that you've built through this hackathon to bring it to market. From finding co-founders, building business model, sizing the market, and selecting accelerators, it provides a step-by-step guide for a prospective entrepreneur's journey. Finally, our next hackathon will be coming in the next few months. Please stay tuned for further updates. Good morning, good afternoon, and good night from wherever you are, and thank you for tuning in.